Hello class 9. In this video, we will have the quick revision and basic concept of the chapter 8 quadrilateral. So without skipping, watch the full video. Quadrilateral means four-side figure, and the parallelogram, a quadrilateral having the opposite sides equal and parallel. Now let us start with the properties and theorem. Theorem 8.1 says that the diagonal of parallelogram divided into two congruent triangle. Very simple. You can see, and proof is very easy. Theorem 8.2, in a parallelogram opposite sides are equal. Theorem 8.3, if each pair of opposite sides of quadrilateral equal, then it is a parallelogram. Converse. So these are very simple and basic properties you have to remember. In a parallelogram opposite angles are equal, opposite sides are equal, opposite angles are equal. And next theorem, if in a quadrilateral each pair of opposite angle equal, then it is a parallelogram. Converse. And the very important property, theorem 8.6, the diagonals of parallelogram bisect each other. And converse, if the diagonals of quadrilateral bisect each other, then it is a parallelogram. Two triangle we have to congruent, AOB, COD. AOB and COD, opposite triangles. Given that these are bisect, so these parts are equal, you can see, and these parts are equal, and vertical opposite angle, triangles are congruent. Triangles are congruent, then these angles are equal by CPCT, and these are alternate angles, therefore these lines are parallel. Similarly, we can prove these two triangles congruent. See, parts are equal, these are alternate angles, these are also parallel. So opposite sides are parallel, therefore ABCD is a parallelogram. First example is very easy. Second example is very important. Second example says that show that the diagonals of rhombus are perpendicular to each other. Example 2, ABCD is rhombus. We have to prove that diagonal perpendicular to each other. See, we will take these two triangles, very easy. This OD is a common in between two triangles, and diagonals bisect each other. So this part equal to this part, and all sides of the rhombus are equal. So these two triangles are congruent by SSS. Triangle AOD congruent to COD by SSS. So these two angles are equal. Angle 1, suppose this is angle 2. So angle 1 equal to 2 by CPCT. And also linear pair, angle 1 plus 2 is 180. So each will be 90 degree. So it means diagonal perpendicular to each other. Now see student, example 3 is very important. Given that ABC is an isosceles triangle with sides AB equal to AC, and AD bisect this angle, this exterior angle, sorry. Now see student, example 3 is very important. Given that ABC is an isosceles triangle, these sides equal, and this angle bisect by this line AD, we have to prove that these two angles DAC equal to BCA. DAC this equal to BCA. And the second part, we have to prove that ABCD is a parallelogram. इधर बंद का नहीं है ना? Now student, let us have the very simple solution. Since this bisect this angle, so let each angle is x, because it bisects, so two angles are equal, and it is given that these two sides are equal, so let us suppose each is y, base angles of the isosceles triangle. Now exterior angle property, remember studied in the lower classes, if a triangle and this triangle exterior angle, this angle is equal to this plus this. This exterior angle is equal to sum of two interior angles. So in the similar way, this angle PAC, so I am writing directly 2x is equal to sum of two interior, means y plus y. 2x is equal to 2y. So angle x is equal to angle y. So this x equal to this y. Alternate angles. So alternate angles, this gives us the result that AD is parallel to BC. And in the question it is given that AB is parallel to CD. So these two says that ABCD is a parallelogram. X is equal to y gives us the first part DAC equal to BAC. DAC equal to this BAC, and these two parallel pairs give us the ABCD is a parallelogram because opposite pairs are parallel. Now student, this example 4 is very easy. Now come to the example 5. This is important. In example 5 it is asked, show that the bisectors of angles of parallelogram form a rectangle. These are the bisectors, they are intersecting and form the PQRS is a rectangle. This we have to show that this part is a rectangle. This we have to show that PQRS is a rectangle. See, let us have a quick solution. Since this is a bisector, so let us suppose each is 1 1 and this each is 2 2. And interior opposite angle sum is 180. So this D plus A is 180. D means double of 1 plus double of 2 is equal to 180. So angle 1 plus 2 will be divided, this 180 is 90 degree. 1 plus 2 90. So in this triangle DAP, by angle sum property 1 plus 2 plus this angle is equal to 180. This angle DPA. 180 and this is 90. Therefore DPA angle is equal to 90. This 90 will subtract here. Instead of the 1 plus 2 we will write 90. So this is 90. By vertical opposite this is also 90. In the similar way we will prove this side, this plus this 180 and 90. So this will also 90 and this is 90. And in the similar way we will take by this triangle AQB. This angle 2 plus 2 and this suppose 3 3 is they are bisected by bisector. So double of 2 plus double of 3 is 180. Again sum of the interior opposite angles. So angle 2 plus angle 3 is 90. So by angle sum property this Q will also 90 degree. In triangle AQB, this 2 plus 3 plus AQB is 180. So AQB will be 90 degree. AQB 90. In the similar way we will take this triangle, this will also 90. These four angles are 90 degree. It means this is a rectangle. It is a sufficient property to prove it rectangle. Now student, let us see the exercise 8.1. All solutions I uploaded on my YouTube channel. You can find in the playlist class 9 maths. We will do only here the very important questions. In the whole exercise, this question number 7. This is very important. Given that ABCD is trapezium and this line is extended here and construction is also given in the question. You have to join this E to C. AB parallel to this CD and this side AD and BC are equal. In first part we need to prove that angle A equal to angle B. Since this is a trapezium and given that this AB parallel to CD and this construction we have done parallel to this AD. So these two sides are also parallel. So opposite sides of this quadrilateral are parallel. Quadrilateral AECD. So this is a parallelogram. AECD is a parallelogram and opposite sides are equal. AD equal to EC. But it is given that AD equal to BC. So these two give us the result EC equal to BC. AD common. So EC equal to BC. So this is an isosceles triangle. These angles are equal. So let us suppose these two equal angles are XX. And this is A and this is B. Now see, B plus x is 180 by linear pair. Angle B plus x is 180, and this A plus E, instead of E I am writing x, A plus E or x you can write is 180 interior opposite angles of this between these parallel lines. So these two RHS equal and this XX common. So these two imply that A equal to B. So first part proved, A equal to B. Now come to the second part, C equal to D. We have to prove that this C equal to this D. Let these two angles are x because these two sides are equal. Now see, D equal to x, opposite angles of parallelogram, and this C equal to x by alternate angle property. Okay student, the reason you will write here opposite angles of parallelogram, and this reason C equal to x alternate angles. So these two give us the result angle C equal to angle D. XX is common. The second part also proved. Now come to the third part. We have to prove that the triangle ABC congruent to BAD. ABC. For this we have to join ABC BAD. See, very simple. This AB is common base in between these two triangles, and these sides are already given equal, and A equal to B just proved in the first part. So triangles are congruent by SAS. AD equal to BC and A equal to B we proved in the first part, and AB equal to BA, this common. So triangle ABC congruent to BAD by SAS. Now student, the very important part of this chapter, midpoint theorem and converse of midpoint theorem. Midpoint theorem proof I already uploaded on the YouTube channel, and the basic explanation I am giving you. The very simple midpoint theorem means in triangle, if two midpoints of these sides join, then this side will be parallel to this side and this side will be half of this side. Means if it is ABC and it is DE will be parallel to BC, and also DE will be half of BC. There is a very useful relation in this kind of the question. Suppose a numerical comes, this length is given, so you can do it half, or this is given, you can do it twice. This is a midpoint theorem. Now converse of midpoint, if this is a midpoint of this side and this line is going parallel to this line, and this part, first part, it was not given parallel, just given these two are midpoint and we join, this is parallel to this and this is half of this. But in this segment, converse of midpoint, this is a midpoint of one side and this is parallel and we join, then this will also the midpoint, means this line will bisect this side of the triangle. This is a converse. Theorem 8.8, midpoint theorem, the line segment joining the midpoint of two sides of triangle is parallel to the third side, and also is given half of this one. Converse, the line drawn through midpoint of one side. See how to remember, how to differentiate. In midpoint theorem, these two are midpoints, then this will be parallel and half of this. But in converse, only one is a midpoint and parallel to another side, and this is parallel to another side, so this will bisect this side, bisect the third side. Now question based on this example 6. See, it is a triangle and these are the midpoint. In short, I am explaining you. Show that ABC is divided into 4 congruent triangles. You have to prove that these are 4 congruent triangles. It's very simple. These are midpoints D and F. So this DF will be half of BC and parallel to BC. So half of BC and parallel to BC, so half is BE. So this will be parallel to this side. So DF BC parallel and equal, and these are also parallel. So this is a parallelogram, and property of parallelogram, diagonal divide a parallelogram into 2 congruent triangle. So these two parts are equal. Similarly, we'll take this one and this one here. This DF is also equal to EC, because it is half of BC, means it will equal to EC. So in the similar way, DECF is also parallelogram. So diagonal divide into two parts, so these two are also equal. In the similar way, we'll take this parallelogram ADEF. So these two parts are equal. So we can prove it. All triangles are divided into equal parts, equal congruent triangles. Very easy solution. Now this example is based on the converse of midpoint, and this we saw in the example 6. We saw the application of midpoint theorem. Now let us see the application of converse of midpoint theorem. Let us see the question first. It is given that LMN are three parallel lines. These are three parallel lines intersected by P and Q, such that cut the intercept AB and BC. AB and BC are equal. We have to prove that this DE and EF are also equal. Let us see here the diagram, because this is an important example. These two parts are given. In short, I am explaining. These two parts are given equal. We have to prove that these two parts are also equal. These are parallel lines. We will join these corners. Now see, in this triangles, these are midpoint given, and this is parallel to this one. So it means by converse of midpoint, this will also the midpoint, because converse of midpoint says that in a triangle, if this is a midpoint and this is a line parallel to this line, then this line will bisect other side of triangle. In the similar way, this is a triangle, this is given are equal, so these two are also equal. Now see, in this triangle, again line is moving here, so this is a midpoint, this is a parallel of this one. So in this triangle, see, in this triangle, so this will also midpoint, hence prove. Now come to the exercise 8.2. All solutions I uploaded on my YouTube channel class 9 maths playlist. And the parallelogram AB, CD, E and F are the midpoints of AB and CD. This is a midpoint, this is midpoints, means these two parts are equal. Show that line segment AF and EC trisect by BD, means we have to prove that these parts are equal. DP equal to PQ equal to QB. Now see student, it is given that ABCD is a parallelogram, E and F are midpoints. We have to show that these three parts are equal, means DP equal to PQ equal to QB. First of all, we have to prove this AECF is parallelogram. How it is a parallelogram? This line is parallel to this line, because this is opposite sides. These opposite sides are parallel, so these parts are also parallel. And also opposite sides are equal, so these parts are equal. So we can write AB parallel to CD, AB equal to CD. This is a property of parallelogram. Therefore AE parallel to FC and also AE equal to FC. So this implies that AEFC is parallelogram. Now come to this triangle DQC. Triangle DQC. F is a midpoint, it is given, and this line is parallel to this line, because these are the parts of this parallelogram. So these will be parallel to this, and this is a midpoint, so P will also midpoint. So we can write DP equal to PQ using the converse of midpoint theorem, because in converse of midpoint theorem just we saw that if one is a midpoint and this is a parallel to this, so this line will also bisect this side. So in the similar way, this bisecting this part. In the similar way, you see the triangle BAP. In BAP, see this E is a midpoint given. So by converse of midpoint theorem, this Q will also midpoint, because this line is parallel to this line. These are the parts of this parallelogram. So this shows that BQ equal to PQ. So these two implies that DP equal to PQ equal to BQ. Hence AF and EC trisect the diagonal BD. So my dear student, this was just quick revision of NCERT chapter 8 quadrilateral. If you are having any doubt, you can write in the comment box. Now in next video we will see the next chapter. Thank you.